Recording? Yeah. Okay. Thank you very much, everyone, for joining the webinar. Myself, Sachin Fulsundar. I am a simulation specialist working for Autodesk India Private Limited and taking care of the Autodesk simulation technical portion of the Autodesk simulation products. So, what's there in the agenda for today's webinar? So, with this, I want to take you through the Autodesk simulation portfolio. This is a good opportunity for me to showcase Autodesk simulation portfolio to all the beginners and who has recently started their career as a product designer or the veteran user of the CAD solutions, but doing the product designer for decades, but not gotten chance to look at the Autodesk simulation portfolio I want to use. And then I want to break the myth of that Moldflow is only a simulation analyst product, and it's not that something can be used for the plastic product designers. So and I will do that using Moldflow design. So I want to show them the Moldflow design's capability, how it will be complementing to the existing workflow, not to create an one-step hurdle onto as they develop the product, but it should complement to their existing workflow. And then little deep dive onto the simulation part, again a plastic simulation, but people who demands little more than the just upfront, but at the same time they want to keep less efforts in preparation, model preparation, and give a valid feedback to their managers or their client or their customers. This is how it is going to work. These are the challenges they will face as they manufacture the part. But one thing that remains intact is the ease of use. So both these products, Moldflow Design and Autodesk Advisor, are the products that are designed in such a way that minimum effort would be required to create the model, to set up the model, and you get best of that one. And finally, I want to show them show you the product demonstration so that ease of use. So as I said, I'm Sachin Fulsundar. I work for Autodesk India Private Limited. I worked as a technical specialist focusing on to the simulation product, and I will be your speaker for next 50-55 minutes or so. Okay, let's get started with the simulation early and often and changing your process effectively. So this at Autodesk, we are focusing on to the fundamental issues with the use of simulation tool like Moldflow. Looking at the typical product development cycle, if you look at the typical product development cycle, going from the concept, the way the product and the way the product goes into the field, the ability to make the changes or the improvements or improvement in the product performance declines over time. I hope you agree with this one. And this is because the cost of each design change goes up as more and more constraints are placed onto the product. And cost is a very, very critical factor, because as you go through this concept to the design, engineering, and testing, I'll put my cursor over here, sorry for that. Okay, as you go from the concept to the design, engineering, and testing and manufacturing, the ability to change reduces, because the cost and the time that you have put in has to re-put or in the re-engineering of these products. So, but if you look at the traditional way of doing it, it's traditional way of validating is more onto the testing. We still, find it more efforts or concentrated efforts are put at the testing area to validate the product before it goes to the manufacturing and the field. Nothing wrong in that one, but in today's scenario where the products are changing and the life cycles are reduced, we really need to get out of this traditional way of doing or designing the product and adapt to the upcoming new technologies which enable you to design or validate your product right at the design stage. And this is how you can put more efforts towards the innovating the product rather than just continuing doing the traditional way of designing the product. So, and this is the area where I want, or the many industries are putting efforts now, changing from testing phase to the design and engineering, seeing that validating this stage would make more benefit in terms of reducing the cost, in terms of time that they spend on to the re-engineering. And this is where the simulation we want it to go from, not replacing the testing. People now think that, okay, simulation is something that is a replacement for the testing, but simulation, upfront simulation, is the next generation or the way forward or future of making things that Autodesk has been emphasizing on that one. So, and it enables the designers and engineers who are the key to the, or the key people responsible for the design. And if we can empower them with the power of simulation, would be a win-win situation for the designers as well as the future coming steps of testing or manufacturing or field issues can be upfront find it out. So with this, I would like to take an opportunity to show that how Autodesk is investing into the simulation. And if I got a chance to meet some of you, I've been talking about that and giving you the overview of what Autodesk is doing into the simulation field. And Autodesk has been known for its 2D and 3D world leader in 2D and 3D products, but equally has broadened its portfolio in simulation. So right from 2005 till last year, I didn't got a chance to put up the products that we have put into our simulation portfolio, but till 2015 you can see that right from Solid Dynamics or Plastotech, these are the products that comes along with the inventor for the dynamic simulation or CA simulation, and robots, green building design, Ecotech are the something products for the upfront simulation gets into the Revit, which is a part of our architectural engineering and construction stream. And we have a specialized product like Moldflow, Algor, CF Design, we call it an Autodesk CFD, and Firewall Composites, Helios products. And then last year we recently acquired a best of the FEA technology from the NEI software, the Nastran product. And all of these product has a much broader portfolio, in not only as a specialized product for the analyst, but a portion of these can be used for the upfront simulations. And this is the way we will be designing the product if you want to put less effort in terms of, or reduce the efforts in designing the prototypes, testing, and go faster into the market. So with this, I don't want to show you a chart or something, but this is the something that our simulation portfolio can help the designers and engineers to answer some of the questions. Rather than they asking the questions, let the simulation give the answer what we can do. So some of the very unique questions that designers or engineers comes into mind: will it fail, and how the failure would occur, or can I optimize my product, where will the defect will look like? So they don't want to, if you look from the designers or engineers perspective, they don't want to go into the detail analysis, but they are equally concerned onto their product before they hand over the product to the manufacturing team or to the analyst, saying that will my product will be manufacturable, or I'm making a very blunder mistakes which the products cannot be manufactured or so. And these are the product portfolio I'm showing, not only showing you in from the Moldflow point of view, but in terms of the structural, in terms of the plastic flow analysis. It could be a fluid flow analysis, or it could be heat transfer, or it could be a composite. So all and in all, they form an actually a family of products which would enable, you know, our plastic designers and engineers to answer some of the questions which comes into their mind as they design the product. And these questions are raised because they are concerned about the product that they design, and it should deliver to the performance up to their expectations. And as I say, that Autodesk has a broad range of physics in terms of the fluid, mechanics, composites, and plastics. And we have divided all of these products as an upfront, design optimization, and advanced material. So all of these products comes as an upfront optimization product. So when I say upfront, they sit in your CAD system, and this will complement the product design process and not creating an extra step. I will show it when I will demonstrate the Moldflow design and advisor product. And today, since we are today only on focus on to the plastic stream, but given an opportunity in the forthcoming webinar, I like to demonstrate how in terms of the CFD, how in terms of mechanical simulation, how in terms of in composites, upfront simulation can be done as they designs the product for the each of these physics. Okay, so with this, we will get started with the upfront simulation. So when I say upfront simulation, what it means? So something can easily take up and help you as you design the product without adding an additional step. So something like an, you know, advisor comes into the six besides you, enabling you to design the product as per the constraints and upfront the rules, because each of these streams, like if you say when you're designing a product for a sheet metal, if you're designing a product for the plastics, it has to follow some rules. And why do we follow some rules? Is that it is manufacturable and you reach to the expectations which is set by your client or your customer much in an easier manner rather than doing a trial and error. So something with the simulation early and often, I like to demonstrate into the some of the very easy product in terms of for the FEA. If you got a chance, now is in the age of the smartphone age, if you have an access to the net, and you can go on to your app store or into the Google store and try finding out something called an force effect from Autodesk. So it's a like an, you know, line diagram type of analysis which will enable you to just, you know, click a picture, sketch something, put the force, and it will give you the reaction force. And this is something upfront design. You are not going into the detail analysis, but equally you are getting a feedback. What is my reaction force? What is my, you know, the force if I applied this much? What would be the reaction, and so on? It is based on to the line diagram. Enough information. I would say 50 to 60% of information will get right up front before you go into the design product. So look at that, the force effect, try downloading it. And then we have something, a product called as an flow design actually. And this project was earlier called as a Falcon, and it was embedded along with the alias but now this product is available as a standalone also. You can search onto the Google or something search engine and try finding out for the flow design, and it's very intuitive. You start, just download the product, and trial version is available for this product, and it will show you the information onto the CFD as in like a drag, what is the force coming up, and it will show you the vertex formations and so on. And nothing, you don't really need that CFD knowledge to get started on to working on this one. So that is the best beauty of the Autodesk product, is they design it in such a way that ease of use is a main criteria they put in the mind when they design the product. And then we are going to discuss more on to the today is the Moldflow design and how it will enable our plastic product designers to create some of the great or best of the products into the market. Okay, so this is force effect, flow design, and Moldflow. Force effect, flow design, and Moldflow design are the three products that I'm talked about, and I'm going to focus more on to the Moldflow design in the forthcoming slides. But before I go on to the actual product, I want to take in time how each of the personas they play a role in creating this product. So in a typical industry, when we have a designers who create a like a CAD or a concept type of products, maybe a surface. They get the information from the OEM, and then we have an engineers who create a best of the features on them, so that the products gets assembled to the rest of the product or assembly. But in many of the industry, these two of this job are done by the single, or many a times, three of these job, a designer, a engineer, and an analyst, is sometimes done by the single person actually. But if you do a typical industry or plastic product design, we have a designer, we have an engineer, and then we have an analyst. So analyst is particularly focused onto the much in-depth simulation. So today's webinar, I would say not much onto this persona, but I will try to concentrate on more onto the designers and engineers. Let's give a more focused onto these personas, because they are the real people who start from the scratch, build up the products, and they deliver it to the manufacturing stream, and so as they also deliver it to the analyst for the feedback. And then let's start with the designers. Then we have a product for Autodesk Moldflow design that I talked about, and see where it fits into the workflow. So if you take a right tool at right time, if you see a product development workflow, a typical development flow, you get a request from your client, customer, or OEM, or it could be a self-innovator. You start with something with the scratch, and you try to figure it how would be the cost would look like for this product as I go building up the product, and they start building up into the 3D part model, and then if given a chance, they will do a FE analysis before the final product has been submitted to the manufacturing team. So manufacturing team comprise of the mold design, and then go into the mold optimization and processing of that, and then we do visualization and report and documentation. So this is completely a typical workflow. But in the main portion, if you see, when you talk about the upfront design, is the 3D part modeling, and this is a very, very critical phase. That's the reason I thought of showing you the first slides, where how as you go through the complete product development process, right from concept to the field, the ability to make the changes in the part reduces, because it is not only going to affect on the times that you have spent, the cost, the investments, the manpower that has gone. uh, uh, if you're given a chance, you should make the changes right at the 3D modeling, and this is the area that I'm going to focus and see how Moldflow design can help a product engineer and a designers as they design and do a validation right into their interface. So let's talk more on to the Moldflow design on this. So validate the design for manufacturing. That is the main focus of the Autodesk Moldflow design. It's like a new designer oriented part design validation products. It is always on. As I say, it's act as an advisor sitting right next to you, helping you as you design the product. It is not something that you check after design is completed. That option is also available. I would say that is a more onto the manager level action. Like manager get the design form, hit subordinate and try to check whether he is following that rule. That is also possible. But I would give a more importance to the part designers, because they are putting the efforts, and I want to make sure that when they are putting the efforts, they are putting the efforts into the right direction. And it is always on. It gives a real-time feedback. It's a plugin to the Inventor, Pro Engineer, and SolidWorks. So any of these three CAD platform are, if you're using it, Autodesk Moldflow design can sit right into your CAD system and enable you to design the product or validate the product as you design. And it's also available as a standalone product, and it can import all major CAD platforms. So it could be a NX file, it could be a CATIA file, or it could be a solid H file, or it could be a step file or IGS file where you get it from your vendors, suppliers. You can import it and you can do the validation and upfront. In and all, it works on the three, I will say traffic lights. I want to talk because that's where I can resemble, do the more similarities or resembles to the cautiousness or the feedback, which I can recall it very fast. So it's a revolutionary tool that helps the product designers to develop a digital prototype with the manufacturability in the mind. So it works onto the sorry, excuse me. As I said, that it works onto the while you're designing the product or within your existing CAD system that talk about the Inventor, SolidWorks, and Pro Engineer. Any of these, if you have a CAD system, it can say, and it works onto the as I said, three traffic lights actually showing you the information. Green is something, its product is manufacturable, it will give you the manufacturing percentage. Yellow is something, a caution, you are little high on the cost or something, or I'll get, and red is something alarming. I mean to say you are making a little more mistakes which could challenge you in manufacturing the product. So very simplistic. Green okay, yellow is caution, and red is something is alarming situation. And it will also focus onto the areas where these are lagging. Means it only doesn't give you the feedback, but it will also take you through the areas where the problems are there. It is always best to suggest, oh, you made mistakes, but where do I made a mistake? Is something should go and check it. Okay, this is the area where you have made the mistake. Okay, how do you get the most value out of your simulation? So previously, the simulation were disconnected from the design. You mean to say, if you look at a traditional way of 5 years back, or say 10 years back, you used to do a design, then simulate, then come back again to the design and simulate. Then many people, they design a plugin actually to push in the model form directly from the CAD to the simulation, and simulation to the CAD. But we didn't have much of the products that can work within the CAD environment. And Autodesk really think from the designers and product engineers point of view, they want the product right when they are designing the product and giving you the feedback as they design the product. So it is not to irritate them, but to guide them actually when they're designing. And this could be a scenario when a new engineer is started building up the product. He is not much aware onto the field scenarios or manufacturing processes. This could be a best tool to get started him or enabling him, increasing his confidence as he designs the product. So integrated simulation within the design. So the same GUI, I'm showing you the GUI of the inventor, but the GUI would look like the similar for the SolidWorks and to the pro engineers, and the same GUI where you are designing is the same GUI where you are going to do the simulation, but simulation with the ease, not extra step. It is going to complement your existing workflow. I want to re-emphasize on that. It's not going to increase your any steps, but it's going to complement. When you submit the design, you are much confident that I have designed, I have put my best efforts to design which is manufacturable. So it works on to the plugin to the Inventor, Pro Engineer, and SolidWorks, and includes the indicator to help you evaluate all the manufacturability, cost efficiency, and plastic material impact. So three things it works into: the manufacturability, cost efficiency, and plastic material impact. So using a intuitive traffic light style plots, green indicates everything is good, yellow there are some potential issues, red means there are show-stopping problems you need to address, and anytime it finds the potential problems in any of this area, alert lets you know as it happens. So it works as you design the product and focusing on manufacturability, cost efficiency, and plastic material impact. Let's see. So it's a real-time simulation. So I want to show you the short animation on this. I don't know. Okay, let me uncheck this one. Okay, pointer. Okay. So yeah. So this is an GUI for my inventor, and I just see that I'm designing a product and I am updating the scenes, and you can see that as I update my design, my flow patterns are also changing. So, and all of the FEA simulation or anything that works onto the finite element analysis, I want to show it again to you on this video. Okay, I'm designing a product and I'm doing a flow simulation, and meshing and everything happens into the background. So designers don't have to worry on that. How do I do meshing or anything? Everything is being taken care by you, and it works onto the very simple system. Even a 2 GB of RAM machine is good enough. You don't really have to look out for the machine change or something that the plugin is, and it's not going to hurdle your existing. It's not going to slow down your system or something. It's going to be there, but adds the complement your design workflow. So what are other things that it can real-time do the simulation? It can check on the weld lines, seam marks, and injection pressure, because designers are much worried on where do I fall these weld lines, how do I the seam marks are going to look like as I design the ribs. These are the main concerns for them. It's a manufacturability point of view, because many times they design the product and the failure happens in the field, and many times I would say 80 to 90% the failure happens at the weld line location, because that is the weakest spot into the product, and if it is subjected to the excessive loading, the crack will initiate, and they are much concerned. But many times designers or product engineers are not involved into when the manufacturing happens. They just submit the designs to the tool maker, and tool maker, as per his convenience, give the gate locations, and And finally, they land up into the issue of like a failure of the product. But the true responsibility again lies with to the product engineers, and upfront simulation gives the chance to look at these scenarios of where the weld line is going to fall, where the sink marks are going to come, how they are going to look like, and injection pressure. So this was good enough. I mean to say, from the design for manufacturing point of view, this is good enough. But something, you know, Moldflow design goes beyond that. It also enables you to check on to the finished part preview. I mean to say, how the product is going to look like after the manufacturing defects are to be there actually. So these are the like sink marks, weld lines, and the air traps are the, it comes all together and shows you, okay, this is how the product is going to look like. Interesting. And for manufacturability indicator, it also shows you the areas of high wall thicknesses, okay, draft angle and undercuts. Many times, you know, when you are designing a product, you land up creating a draft angle, you know, undercuts, and you are not noticed because you are too much involved into the product design that many times just for giving some other features you land up creating undercuts. And as the number of undercuts increases, the cost of the tooling also increases, and sometimes we make such a blunder that product cannot be manufactured. I mean to say, if you want to create that undercut, it cannot be removed out of the tool, and that becomes a showstopper. Now, do you think that I'm showing something very different than any of the CAD systems? Okay, you can always check the wall thicknesses, draft angle, and undercut in any of the CAD system. But what differentiates the Moldflow design from the rest of the CAD system is it is intuitive. It's real time. It's real time in the sense as you design the product, as you are creating the product, it will give you upfront information on this. So all wall thicknesses, draft angles, and undercut. As soon as you create this, misses this, it is going to give you alarming or situation that where do I have missed it. It's not just like you are missed the draft angle, but it will also show you the location where you have missed the draft angle. Need not to go into like a traditional way. Each phase you're checking whether draft angles are missed or not. Okay, that's good. It also talks about the cost efficiency indicator. So it also talks about the mold cost. It's all driven by the how many undercuts you have, how big part is this. Based on those rules, it gives the information onto the mold cost. But it talks only onto the three of the things. The mold cost is high, less, and so on, but it doesn't give really, you know, feedback in terms of exact values. But we do have in provision to, if you're looking for that exact value in the forthcoming slides. So material cost, like if you choose, you know, nylon material or PBT material or polycarbonate material versus the polypropylene material or LLDPE material, that is gives the information, okay, your material cost is going high. And so as the production cost is all driven by the material and the wall thicknesses in the part. If you're going to have a much higher thickness wall, it's going to take a little longer time to cool the part actually, and so as the going to increase the production cost. And if you're going to use the expensive material, then also the production cost is going to go up. And it also talks about the sustainability, like the carbon footprint, recyclability, and the energy required to create this part, and the water required to create or manufacture these parts. Okay, these are more into the, you know, the European countries or North America, where they are a little concerned on to recyclability, where the OEM has to pay for the recyclability for the each of the plastic part produced. But these indicators are also available if you're interested into the carbon footprints and so on. So in a summary, this is an intuitive product working right into your design interface. You don't have to learn a separate product. It is an advisor sitting next to you, giving you the information onto the cost, sorry, manufacturability, cost efficiency, and material impact. So these are the three regions where it will help you as you design the product. With this, I have a very short video onto the Pro Engineer and CREO interface. I will show you the actual demonstration onto the using the Inventor, but for the people who are using the Pro Engineer or a CREO for creating the part, this could be a best example. So I'm into the Pro Engineer and I'm doing a CAD modeling, and as I see that I have three indicators over here: the manufacturability, the cost efficiency, and material impact. So each of this information, okay, it's a small box, so it is pretty much very much manufacturable, and it also gives a percentage. Higher the percentage, more the chances you have. And this comes as a plugin. You can see that Autodesk Moldflow Advisor Design is a plugin that comes actually add-on, and you can on off, and it's a network license. So if you are not using it, you can off and you can pass it on to your colleague. And then we have something called as an injection locator. By default, it goes and check out to the best location in the part, and you can do the fill analysis. And now I'm updating the design actually. So as soon as my designs are getting updated, even the flow patterns is going to update. Everything happens into meshing, and updating of the meshing happens into the background. You can see that it is getting refreshed as is this one. So, and you are running the animation actually. And this is within this. Let's look at the more complicated part now. Sorry, I'm very sorry. So this was okay. Let's look at little more complicated part where it shows the manufacturability as 60%. It shows the manufacturability as 60%, and we have some issues related to the cost efficiency, and material impact is not that cost. So I'm going to start, and then manufacturability is where the wall high thickness, it gives the information on the high wall thickness variation. So these are the areas it directly locates. Oh, these are the areas where I have invalid my rule. Okay, you can set up the rules for the where you can think that if you exceed this much of the thickness, it should show you as a hall wide or high wall thicknesses. And then undercuts, draft angle, weld lines, but you can also look at much of the things. So undercuts, if you see that the pull direction you can set up. If you don't set up the pull direction, it will by default, it will be a XY plane, and the Z direction would be a pull direction. And then something like draft angles you are missing. It will give the information where the draft angles are missing, and you can always go and check it out. Those are the areas where I have missed up the draft angles. And then is something the weld line injection location. You can change the injection locations. You can add the injection location as well to check out your filling pattern, and based upon the injection location, it will give information on the weld line actually. So these are the areas the weld lines is going to form. And then the most important thing is the seam mark. It will also give the information on the seam mark, but what interested is to look at the finish preview, how the seam marks are going to look like actually. And then once you have that into the, it will also give the information onto the pressure filling actually, how the pressure filling is going to look like, and then how much pressure would be required to fill the part. And it also talks about onto the mold cost. It's very high. Our production cost is very high, and it all depends upon the your part wall thicknesses and number of undercuts you have it. So this defines the mold cost, and the production cost is altogether driven by the product wall thicknesses and the material that you use. You can change the material very quickly and check how it is going to impact onto the product cost. And material library is altogether taken from your CAD system. So whichever CAD system you are using, it could be Inventor, it could be a Pro Engineer, or it could be a SolidWorks. the whatever the material that it has, the plastic material it has, you can take it for the analysis. You can create your own plastic material as you create in any of the CAD system. Okay, so this was the information onto the mold flow design, and let's talk about little more onto the preliminary simulation, and this is little over and above the mold flow design. So I want to show you a little in depth, but again I kept the one thing in mind: it should be ease of use. It should not create an, I'm repeating these steps again because when we say that a designer or engineer is going to do the simulation, they think that it is an added step into their workflow. It's not going to complement. I want to re-emphasize, it's going to complement. It's not going to take much of your time when you are doing a simulation, but when you design the product, you go with the confidence. So right tool at right time. So different, again I wanted to focus on to the different personas. We talked for the designers very quickly when they are designing it, and I'm going to talk something more for the engineers actually. And these are the guys which look a little more in depth in terms of the costing, in terms of the tooling, but they don't want to be an analyst, but they want to make sure that they are doing little more than the designer, because they are very closely associated with the manufacturing, if I'm not wrong, because they interact with the manufacturing team, they interact with the tooling team, and so on, and very closely associated with them. So Autodesk Moldflow Advisor would be a tool that will give more information as they design the plastic product design. So Moldflow Solutions, it's a directional tool for the product designers and a tool maker. So little in depth, but again I want to re-emphasize and I want to say that sorry, excuse me, it works onto the meshless technology. It works onto the meshless technology. Okay. So when you say meshless technology, everything happens in the background. You don't have to put an efforts to create the mesh and so on. Since it's a directional tool, the results are I would say are how closer to the manufacturability. Now that question comes, we really need to take the analyst into the picture, but this is the tool to enable you to manufacture the part. Okay, it's not the tool that you try to simulate as an scenario. Then for that we have a much specialized tool, and it's a job of the analyst. You need to put more efforts to get that results, but targeted at the preliminary part designers and mold designers. This is what I want to show it in today's webinar. So answering some of the fundamental manufacturing questions: will my part fill? Where the weld lines and air traps are going to fall? Which material I should use? So Advisor has an access to the material library, same as that Moldflow Insight of 9,500 and 30 plus grades of thermoplastics. You can choose upon that. It will help you to locate the gate location with the number of gates and so on, and also talked about the part wall thicknesses, where the part thickness is less, where the part thickness is high, and so on. So we talk what results it gives. So if the short is going to happen, where the short is going to happen, what are the results for the short weld line. It will give you the information at what temperature the weld line is forming, what pressure the weld line is forming. So little more information from the mold flow design, but with the less effect. And the seam mark intensity also you can find it out. It not only show the depression of the seam mark, but it is going to give the information in terms of like in microns, like in 50 microns, 60 microns, and so on. That informations can be found right out. So little in depth on that one. It will also enable you to create the feed system with ease. You can design runner, sprue, gates. As I said that it has an access to the more than 9,500 different grades of thermoplastics and 250 grades of thermosets, but thermosets analysis is not possible into the Advisor. Still you can give an access to the thermoset library, but it will not work for the thermosets material. Indicate ranking of the material in terms of the which is material having the best of the information from the manufacturability, and that depends upon the accuracy of the, and that also drives the accuracy of the results. Cost estimator. Now many people, they want to have the part cost. This will help them to create a RFQ, so we can use the Moldflow cost advisor actually, where you put in the information about the part, runners, and it directly takes in you information of the scrap percentage and so on. So if you put this information, it will give you the per part cost actually. The information that you don't have to fit in is the part, runner, gate, and the cycle time information that will be taken from the from the analysis that you do, and then you just has to put in the information about the per shift cost, and so you can, it also has automatic report generation and intuitive online help, and you can use the communicator for sharing the results as well as with your vendors or your suppliers. Very interesting. So Moldflow Advisor solution is also help you in deciding the automatic gate sizing. So it goes little helpful for the tool makers. So what should be my dimensions of the gate? It automatically updates. If you say, okay, I want to update and optimize it, it also updates the gate sizing also. And it, excuse me. So provide the gate specific design advices, indicates that excessive shear rates are increasing or temperature is rising in the gate areas and in the part also. So it's like, enabling, showing not only the issues, but it also recommends what advice you should do or what actions you should do to clear those results or clear those issues in your part. So with this, I want to show you the actual demonstration of the part. So I will start with the first with the Moldflow design. I have an inventor as a CAD system, and I will try to show it to the. I know it's a little tough to over the web to show the actual demonstration, but I will put my best of the efforts to so that product demonstration is seamless. Okay. So I am into the inventor GUI, and I have opened a solid block over here, and as soon as I open some design, this fellow in the corner, you can see it gets activated. It's as soon as it's activated, it gives the information on the manufacturability, cost efficiency, and material impact, plastic material impact. And it's an add-on actually. If you see, it gets an add-on over here, same as for the SolidWorks, so same as the Pro Engineer. I already shown it to you, and you can on and off. If you're not using it, off it, the license is released and somebody else can use it. And when you on it, it gives the information on this. And this is true for the design that is you're building up, and it's also true for the design that you already been designed. So you can import your IGS file or step file, it start working very immediately. So it shows that, okay, manufacturability is 70%, but what is the issues that 70% is causing? If I click on that, it shows that, okay, part wall thickness is too high. If I click on, it shows that, okay, these are the areas where the part thicknesses are very high. And then it shows that, okay, draft angles are missing. So where are the locations the draft angles is missing? These are the locations where the draft angles are missing actually. And I have chosen the material as the nylon. So you can choose the material different. So I can choose the material different over here. It could be a ABS, polycarbonate. So this is the material library from the inventor actually. So same material library is lies for the SolidWorks or a Pro Engineer. So I get quickly started. It shows that, okay, manufacturability is 70%, cost efficiency is 60%, and the material impact is 60%. I'm going to start building up this one. So as I start building, you can see it is getting updated actually. So this is the block that I have created, and now from 66% it has increased to 97%, and it shows only the weld line issues. But let me complete further on this. So let us have a little complex design, and little complex design. Now it has something like an I have created some holes over here. I have created a lip over here, and not much complicated, but I have something like a fixation over here, a block over here, fixation block over here. See how it works actually. Now it shows that, okay, undercuts are there. So it shows, okay, these are the undercuts. Okay. And it shows, okay, I'm missing on a draft angle. And this is on the go. I don't have to run a separate, analysis to check on this one. Now weld line is little more complicated. Before I go onto the weld line, I want to show you the information onto the injection locator bar. So this is an injection locator bar. It's coming here, right on my screen, and it shows best starts the gate location here. But you can move the gate location from here. I'll just move it. So as soon as I'm moving the gate location, you can see my analysis toolbar is changing over here actually. And I have a single gate over here, and I can add the number of gates. Okay, so I added the 3 gates. Now let's look at the weld line location, and before I go into the weld line location, I want to see the filling pattern actually. So animation toolbar, you can see that it's running in the background actually. And you can see that, okay, these are the 3 weld lines that are getting formed because of the flow fronts meeting. And I'm getting a weld line over here as well. You can see that I'm getting a weld line right over here, and onto the back side as well. So if I go into the weld line and I check it, weld line location actually, okay, this is how the weld lines are formed, right? And I can very much delete this one and saying that, okay, I want only 1 gate. Show me the weld line now. So weld line has disappeared because it is forming because of those things. And let's look at the sing mark. So these are the areas where it is prone to have a sing mark actually. Okay, so this was and knife edges are the sharp edges that you create unnoticedly get created, and it becomes a problem when you are manufacturing the tool. It will also show you the sharp edges where though by default it is going to have some radii, but you by unnoticedly you have created, that's called a knife edges. And then wall thicknesses, it talks about the wall thicknesses. It is in inches because my system is in inches, my CAD system is in inches, but you can always make it into the by just going to the environment and try to change it as but it shows you the information on the thicknesses. It shows you the information on undercuts. I already showing you, and the filling also, pressure required. It shows into the PSI because my system is into the LBS system or English system. But you can always check into the metric system, and it will get into the Pascal. Okay, so with this I will complete my design. I completed my design, and now final manufacturability for this part lies at the 80%, and these are the issues it has. I have missed undercuts. It has undercuts. So I'm missing on the draft angles very quickly. So it could be a tool for the managers as well, where they want to check the design which was come to you, and with a click of few clicks they can find it out actually. Show the thick sections in my part. It shows the thin sections in my part. Where are the thick sections? And this could be a cause for the increase in the cycle time. So if you are thinking that my cycle time is going to increase, so which are the sections which are enabling you to change those areas of the thicker sections? Very quickly you can do that. Then in the cost, mold cost or the material cost is not very small because I have used nylon. But if I change from nylon to, let's see, I will say polycarbonate, still it's not showing as a production cost or mold cost is very small on this one. But we can quickly check on to the enforcement and production cycle time. It is showing that 11.6 seconds. But if I change this from polycarbonates to say, I will go into the check into the some other say nylon 66 or uh, polyethylene. Let's go into check into the polyethylene. I want to see what would be the production cost. Now 11.66 was our cost with the polycarbonate. Now it's a 10.8 seconds. So it quickly changes as you change the material as well. So this was a very quick demonstration to you to show you to how this Moldflow design works. But we do have actually a standalone product. As I said that we do have a standalone product for it. Okay. So you can, this is a standalone GUI for it. You can open the design. It could be a IPT file because this is an inventor file that I have it, but you can open all file formats. You can see that it is a step file format, SolidWorks or SAT or all file formats. You can open it. So it has an GUI as a standalone GUI. It is possible to have the plugin as well. So this is an actually a plugin or a standalone GUI. It gives the information onto the so select material. When I say select material, it gives the information onto the materials that are available inside the. You can quickly check on the materials that are available. So it doesn't have the extensive material library as like a Moldflow, but it's good for the product designers to choose upon. And based upon the applications, it's like an aeronautic, automobile, or consumer, or electrical. You can check upon those applications. It has a configurator as well. So configurator is something best for a manager to check upon, like what should be my wall thicknesses in terms of the percentage. So how you set up those indicators, what should be a red indicator for you, what should be a green indicator for you based upon the nominal wall thicknesses, and it can be saved and it can be also be saved as a default value across the organization, particularly for the bigger organization. If they want to have rule configurator, you can do that as well. So it shows the filling pattern animation, the same as choose the best gate locations, and you can do the animation. And so something it's very beautiful in this is the finish preview of the part. So finish preview is best over here. You can change the material properties. And defects, you can show the sigma mark defects. And you can see, like, sigma mark is going to look like how it is going to look like. You can have shiny surfaces or unshiny surfaces and so on. This is how it looks like actually. You can see that it also gives the information on the weld line that is getting formed and so on. Okay, this was a very quick demonstration for you can save the images for if you want to share it with other. Okay, so this was very quick. And then if you are done with this one, if you're satisfied with the design that you do, you can quickly pass on this information export to the Moldflow advisor. So this design from Moldflow design can be exported to the Moldflow advisor, and I'm going to show you that how quickly you can do a analysis into the Moldflow advisor. So it is again a tool for the engineers, and again I say emphasizing on it's a tool with the ease of use. You don't have to be analyst to be working on that one. So I'm going to open a file for you in the advisor. So I open here the advisor, and then I am going to show you a little more on this one. Okay, I'm going to push this design in front of you. I'm going to push this design from let's push it from the inventor. Okay, so that makes more sense for the people to understand. So I am into this one, and you can see over here export. There is an option called export. Excuse me. To the Autodesk Moldflow Advisor Ultimate. I open it. It's going to open it into the advisor. It is asking me where do I locate it. I will say a sample. Then it is asking me, okay, this is a part, next. This is something I'm doing it very live in front of you. So it's just creating that model. You can see that model pops up over here. It taken a default unit. I will say next. That's it. Not have to do anything. It shows that it's automatically going to clean up the model, automatically check the suitability for you. Nothing that you have to do it actually, that a designer or engineer or need to do it. Just click next. It's everything it's going to do it by for fixing the model, creating the mesh. It shows that okay, dual domain is the best for you, and I will say finish. Once you say finish, model is open into the advisor. You can see that I have just opened this, the same part that is available for you. Okay. So once in your advisor, you can quickly get started onto the. I have opened the other project for you. Let me open. Give me a second. So I have a DFM. Save the changes. Yes, I will say changes. Yes, and then you into the Moldflow design. And some of the things that you can do into the Moldflow advisor is check onto the nominal wall thicknesses. It has option, you can examine that. So it's based on the meshless technology. You don't have to worry on creating the mesh. You can have the percentage band, or it could be a value as well. It will give the information onto the draft angles were missing, where it shows the exact value, and this information is not available in Moldflow design actually. So when you're looking for a little more values, you have to go for the advisor, Moldflow advisor, and then undercuts also. Okay. And then you can choose upon the gate location. You can do the gate location analysis. So all types of different types of analysis you can choose upon here. You can do it. So Moldflow design, gate locations, and all stuff analysis can be done. When you're designing, you can ask for the one gate or number of gates or gate region locator. I'll say it shows the gate suitability location where the gate should be there. It gives the information. This is the best area to gate, and this one. And in the log, it also gives the information onto the where the gate location lies. And when you say apply or perform a fill analysis, it will do a fill analysis also. It's just have to click one click, say perform a fill analysis, choose the best gate location and perform the I will say a fill analysis. When I say apply, I will say create a copy. It creates a copy for you, and the gate is applied for you at the top. So everything, and you are ready to run a fill analysis actually. So this is just a fill preview, like we do it into our Moldflow design. But if you want to run, you can run a complete fill analysis also, and you can choose upon the materials. So it has access to all the material library. of 9,500 different grades of material. Excuse me, I'm little exceeding the time that I specified. It's going little beyond that one, but I want to show it to the all my designer and engineer colleagues. So you have access to all the material library. You can do the search and check and find out the best of the material that suits for your analysis and so on. And when you say analyze, it is going to start the analysis. So I have done the quick analysis for you. So it shows the filling pattern for you, how the filling is going to happen with the fill time, very detailed analysis. It's going to show you the plastic flow or confidence of filling, where it is going to have issues or so, and quality predictions. It's going to show you the weld line locations. It's going to show you the A traps. As I said, that weld line, and on the top of that, I can do the temperature also. So I'm overlaid with the temperature falling, but you can always do the highlight with the weld line with the temperature, or you can do with the pressure drop or fill time and so on. So this information is useful when finding out the strength of the weld line. It's possible to do, and it's in the hand of the designer. I don't need to have an analyst to do those things. And you can always pretty much do it onto the multi-cavity also. Like I had designed very quickly a multi-cavity mold. You can design a feed system, or you can design a cooling channels also. So center lines. So you can see that I have designed a complete mold. So complete mold design is also possible to the extent you want to go and explore it. So Moldflow Advisor is something. It starts from the very basic to this one, and very quickly you can create it. You don't need to create just one click. It designs the feed system. With one click it designs the cooling channel on this one. So you have all information, even in terms of the warpage analysis, how the deformation is going to look like and so on. And it also has a value. You can go and examine the values also over here. Okay, so if you want to have much detailed information on this, I would like to personally have a meeting with you and take you through the more of the information if you want to have an advisor. But I try to give the best of the information with the available time. I little exceeded the time on that. But okay, with going back to our slides. As you know that Autodesk complete solution has gone into the business transformation. We have stopped our perpetual licensing, and all of the Autodesk product, including the Moldflow solutions, are available as a subscription offering. So what's the benefit to the customer is that they don't have to do a bigger investment upfront for the perpetual license. They just can buy the licenses on the need basis, onto the like a term basis license is available. So this reduces down the entry level cost to a very extensive and make an attractive proposal to your management. You don't have to invest much, but take a best out of that with the less investment. And this available as a local solve as well as for cloud solving as well. So this is what the term license versus the perpetual licensing. Okay, so low onto the upfront cost, annual subscription term, or it could be a multi term also, or multi-year term is also possible, and it's a network license. So if you're not using it, you can give it to your colleague, and it can be circulated within your organization. So that's the benefit of the term licenses and versus the perpetual licensing. So all of our simulation products comes with a Sim Studio tool. Sim Studio tool is something helps us to reduce the efforts for meshing. Actually, though the meshing is going to happen into background, we want to have the minimum number of elements and make a design more lighter. So Sim Studio will help you to defeature the part, remove those fine fillets or unwanted features which are not required for the analysis, and it works onto any of the CAD file format. It could be a native CAD file format, or it could be a neutral CAD CAD file formats. With one click, it just removes all fillets, and so make your analysis, make your design ready for the analysis. This could be particularly used for the advisor when the engineers want to use it actually. So with this, I like to conclude this today's webinar onto the product designers and for Moldflow's upfront design for the product designers and engineers. I hope it was valuable information to you, and you'll pass this information to your colleagues who are not able to attend today, and pass it on this. So if you want to get in touch with us, you can get in touch with me the following email address and my contact detail, as well as my colleague Dhruva Aditya, who take the commercial portion of the simulation product for Pan India. So his details are also available. And then we have our Microgenesis as the preferred partner for the simulation product. And I like to give the information of Madhav, who is a national manager technical, and his contact details are also available. So but reach out to any of us. We will help you with the further information and see how best we can work with you for those product validation as you design some of the best products into the industry. So with this, I open this forum for the question and answer. If somebody has a question, please type it into the chat window. I will try my best to answer those questions. And if I'm not able to answer now, I will get back to you with those information. So anyone has a question, put it onto the chat window, and I should be able to help you with that. Okay. I'll take one by one. Is it a plugin available for the Annex? Unigraphics is not plugin available with the Unigraphics, but yes, plugin for the advisor for Unigraphics is available. For Moldflow design, it's not available. You can use a standalone version of Moldflow design to do the validation, upfront validation. Do you have a mold and tool simulation tool? Okay, this is what I showed it. Moldflow Advisor is a tool for the mold designers and for the tool simulation. As you see, you can we can model the feed system, we can model the cooling channels, and you can do a front simulation and validate your tool design. Yes, cooling line assigning possible in this software. Yes, you can design the cooling line. I showed it the cooling line, and very much it is possible to do a cooling line design in the Moldflow Advisor. How this will decide the gate location? Many cases may not go ahead with the. I'll take one by one. Okay. Go ahead with the best gate location due to manufacturing constraint. Yeah, there would be a manufacturing constraint. See, but when Moldflow gives the information to the best gate location, it doesn't understand the constraint. But in the Moldflow Advisor, there is an option to give the constraint in terms of the surfaces where you don't want the gate location to be there. You can say that these are the constraint areas. Don't show me the gate location over here. It just removes those area from the gate location analysis, and it gives a information only on the gate location where it's needed. Okay, I hope that this answers. This will reduce the meshing time and visual analysis. Yes, I mean to say it works on a meshless technology. Everything happens into background. It optimizes the mesh, and designer or product engineer doesn't have to work on to the pre-processing or spend time onto the pre-processing. Everything is been. Is it compatible with the CATIA? No, it's not compatible with the CATIA. It's only compatible with the Inventor, SolidWorks, and Pro Engineer. But the standalone version of Moldflow Design is compatible with all the CAD platforms. It could be a CATIA file, it could be a NX file, so you can import and start working on that. How efficient, how compatible is this meshless results and with the traditional simulation? Okay, I'm not comparing here with the Moldflow Insight. See, Moldflow Insight is completely a tool for the analysts. The more time you spend on the tool, more accurate result on. This is a simulation on the go. This is the simulation to find out whether the product is manufacturable or not. Some of the key issues can be highlighted upfront when you're designing the product. So I don't want to get into the comparison in terms of the accuracy or this one, because you are not going to spend much time onto this tool. This is a tool on the go, giving you the information onto the manufacturability feasibility. Okay, is there a plan to conduct the Moldflow user conference in 2017? Yes, this is a very hot topic that we're discussing in the group, and soon you will come to know about the dates and the venue about the conference. So stay tuned. Good presentation, thank you. Appreciate your comments. Does this plugin works on the network licenses of Moldflow, and which CAD platform it supports? So the CAD platform it supports is Inventor, SolidWorks, and ProEngineer, but the standalone version of the Moldflow design supports all the CAD platform. Could be NX, could be CATIA, or could be Solid Edge. You can import those things. But if you want to have an embedded one within the CAD, it should be ProEngineer, SolidWorks, or the Inventor. I hope that answers. And yes, it's a network license. So if you're not using it, you can pass on that information to your colleagues. How accurate is the filling pressure reduction? So as I said, I don't want to go into the accuracy. So this information is pretty good at the start. If you want to do a as it scenario, Moldflow Insight is a good tool. This is a tool for the product engineers. I don't want to compare them with the analysis. It will be a fair injustice on them. Same as like comparing a analyst with the CAD engineer. Analyst will never able to perform the job as that the CAD engineers are doing it. So there won't be a fair comparison between them. Okay, thank you for the session. I appreciate your comment. Thank you. Thank you for attending and taking out your time. So I tried my best to answer your questions, but if you have some more questions, do let us know. I have already given you the best of the information that is available with me, but if you want to reach out to us, you can reach out to us in any of the 3 contacts that I have displayed on my screen. You can reach out to me, my colleague, or our partner, Microgenesis, and they should be able to help you in the best way and this one. So I will there for another 30 seconds. If you have still more questions, I will try to answer. If you don't have any questions, if later on if you have some questions, so do reach out to us, and then we will try to answer to you. Okay, with this, I think there are no more questions, and I will kindly share the link to download the presentation. Yeah, definitely, I'll share whatever the things that can be shared. I will put the link, send it across onto our WhatsApp group, as well as onto the email that I have been circulating to the all Moldflow user group community. And thank you for your time and making effort to join this today's session. I hope it was useful to you. You got some information onto I want to clear the myth about that Moldflow is only the product for the analyst, but it has equally broadened its portfolio for the upfront simulation. Good, thank you very much. With this, I am stopping the recording.